Hello everyone. In continuation to random variables probability distribution numerical problems, we are into now question number 21, which says find the probability distribution of the number of doublets in 3 throws of a pair of device. So it talks about pair of device. So that means there are 36 outcomes which are possible because it is pair of device. All possible outcomes will be 6 square, which is 36. That is clear. Now they are talking about number of doublets. So we will say let x equal to a random variable denoting number of doublets. So what are the possible doublets? Hence, the possible doublets are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So, in a 3 throws of a pair of dice, here we are talking about 3 throws. So, in the 3 throws, none of the throws we may get a doublet. So, clearly, x can take values. So, in all the 3 throws, we don't get any doublets. So, that means it is 0. Among the 3 throws, one of the throw we may get a doublet. Okay. 2 of the throws we may get a doublet. All the 3 throws we may get a doublet. So 0, 1, 2, 3 may be the values not maybe or the values which x can take. Now, next, probability of getting a doublet. So these are the favorable outcomes 1, 1, 2, 2, 3, 3 up to 6, 6. How many are there? 6 outcomes. How many total all possible outcomes? 36. So this will become 6 by 36. So it is 1 by 6. Therefore, probability of not getting a doublet will be 1 minus of the above probability, which is complementary event, which is 5 by 6. Now, let us calculate for each of these x values, that is 0, 1, 2, 3, let us calculate the required probabilities. So, what is probability of x taking a value 0? What does it mean? Probability of no doublet. Right? So, each throw is independent of each other. So I have to write 5 by 6 3 times, multiply 3 times because it is independent. So it will be 125 by 216. Okay. Let's move on to the next page. Probability. What is the probability of x taking the value 1? Means a single doublet. It can be probability of 1 doublet and 2 non-doublets. 2 non-doublets. Again, this can happen like in the first throw, I may get a doublet. First throw, I may get a doublet. And then subsequent 2 more throws, I may not get a doublet. Then first throw, I may not. Second, I may. Third, I may not. Then first 2, I may not. Last, I may. So these are the various possibilities. That means this I can straight away write 3 times 1 by 6, 5 by 6, 5 by 6. So if we calculate this, we get 25 into 3, 75. 75 by 216. That will be the probability of this. Then, what is the probability of getting two doublets? The probability of let me rub it and write it. I will say probability of, okay, I think now it is going. Yeah. Okay. So probability of two doublets, DOU, doublets, and one non-doublet. So how that can happen? It can be like two doublets. So first two I can get doublets. Last I may not get a doublet. Or first I may get, second I may not, last I may get, or first I may not, next two I may. Again, this can be written as 3 times 1 by 6, 1 by 6, 5 by 6. So it becomes 15 divided by 216. Okay. Then probability, what do you mean by probability of x is equal to 3? Probability of getting all the 3 to be doublets. So that means all the 3, 1 by 6, 1 by 6, 1 by 6, that will work out 1 by 216, right? So hence I can say probability distribution. Let me rub this. Probability distribution will be, let me write it like x, then p of x, 0. 0 means we already calculated. 0 is 125 by 216. Okay. Then 1, we calculated above, it is 75 by 216. Then 2, it is 15 by 216. Then 3, it is 1 by 216. You may verify whether the total is 1 or not for all the, after adding all the probabilities. Let's see. 125 plus 75 is 200. 200 plus 16 is 216. Yes, you get the sum of all probabilities to be 1. So this ends this particular session. Further, we'll see in our subsequent session. It will also be a continuation of probability distribution. We'll see that, right? Thank you all.